Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to cover a very important topic that is about probability distribution functions. Now this is a really important topic. With the base of this we will be able to understand different distributions of data that we specifically have, and through that we will definitely be able to solve a lot of problems when you understand about that particular data. So first of all, we'll try to understand the definition. What exactly is probability distribution function? So here, probability distribution function describes how the probabilities are distributed over the values of a random variable. Let's consider we have a random variable called as ages, okay? And it has some data. Now, initially, if we really want to create a PDF, that is probability distribution function, considering let's say that this is a continuous random variable. Okay, it is a continuous random variable. Okay, so what we basically do is that with respect to this particular variable, we go ahead and construct our histograms, right? And I hope everybody knows how do we construct a histogram. Let's say if our histogram looks something like this. Okay, and on the y-axis, you will specifically be having frequency. In the x-axis, you will be having ages, right? Now, in order to, if I say that, okay, I have this particular histogram, I've already explained that if I smoothen this histogram, then I will get some kind of distribution, which looks like this. That basically means this entire random variable can be represented in the terms of probabilities in this distribution way, right? And once we probably convert this, or once we smoothen this histogram, the y-axis then becomes something called as probability density. We'll discuss more about it, what exactly is probability density and how these values are actually calculated. So in this probability density, you will be having some values like 0.01, you may have 0.02, then you may have 0.03, then you may have 0.04, right? And let's say this tip value, right, with respect to this particular mean, let's say this is my mean or median, right? If I really want to take ages, let's say over here the median is somewhere around 55, okay? And if I just plot 55 over here, you'll be able to see that I'm getting the probability density equal to 0.04. What does this basically mean? We will discuss about this, how these values are actually derived. We'll discuss each and everything as we go ahead, right? But understand, once we get this kind of distribution, right? Once we get this kind of PDF function, we will be able to understand about this data a lot, because based on different data sets, we usually get different kind of distribution. We may have one kind of distribution like this. It may be right skewed. We may have another distribution which may be left skewed, right? And each and every distribution of the data is really important for us, because as a data analyst or as a data scientist, this kind of distribution says some basic information about this particular data, and you can assume some of the conclusions out of it. Okay, what are the different kind of distribution we'll discuss as we go ahead, right? But this probability distribution function helps us to understand how the probabilities are distributed over the value of a random variable. Okay, now let's further go ahead and discuss. Probability distribution function are of two types. Okay, so there are two main types of probability distribution function. Probability distribution functions. Now, what are this type? Number one, it is basically called as probability mass functions. Okay, probability mass function. Now, why this probability mass function is specifically used? This is also denoted as PMF. Okay, this kind of distribution or functions are basically created for, it is used for discrete random variable. Let's say if your random variable is discrete, a whole number, at that point of time we will be using, in order to represent the distribution, we will be using probability mass function. The second type that we specifically use is called as probability density function. probability density function. And this is also represented as PDF. And this PDF is basically used for continuous random variable. So if you have a continuous random variable, in order to show the distribution, you will specifically be using probability density function. Now let's go ahead and discuss about probability density function separately and probability mass function separately. Okay. So let's go ahead and talk about probability density function. So first of all, I will take probability density, then we'll go with probability mass. Okay. Or I can also go ahead with probability mass function. Let's go ahead with probability mass function. Okay. Now, as I've already told, probability mass function is a kind of distribution that we specifically use for discrete random variable. Okay. Discrete random variable. Let's take a specific example, and based on this, we will try to construct the PMF. Okay. How does a probability mass function is basically created? Let's take a basic example, rolling a dice. See, when I try to roll a dice, how many different outcomes I have? 1, 2, 3, 4, 5, 6. And this is like a fair dice, okay? Fair dice. That basically means the probability of getting 1 is equal to probability of getting 2 is equal to probability of getting 3 is equal to probability of getting 4 is equal to probability of getting 5 is equal to probability of getting 6. Since I'm saying this as a fair dice, whenever I roll this dice, the probability of getting each and every number are same, and that value is nothing but 1 by 6, right? If I want to probably get the probability of 1, there are 6 outcomes, so it will be 1 divided by 6. I hope this is a simple probability rule. Okay. Now, based on this probability, since this is a fair dice, how do we construct our PMF? Let's discuss about that. That is probability mass function. So in order to construct it, I will go ahead and construct something like this. This will be my x-axis. The x-axis is nothing but the outcomes with respect to my dice, right? And the outcomes are nothing but it is 1, 2, 3, 4, 5, and 6. Okay. 1, 2, 3, 4, 5, 6. In the y-axis, you specifically have probabilities value. Okay. And as you all know, right, probability of getting 1 is nothing but 1 by 6. So I will just go ahead and write 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, and finally 1. Okay. So these are my various probabilities, let's say. But as we all know, the probability of getting each and every number. So the probability of getting 1 is nothing but 1 by 6. Probability of getting 2 is nothing but 1 by 6. Probability of getting 3 is nothing but 1 by 6. So like this, all the probabilities with respect to 6 is 1 by 6 itself. So based on this probability mass function, how do we construct this? The probability of getting 1 is nothing but 1 by 6. So we'll go ahead and construct the building like this. Probability of getting 2 is nothing but 1 by 6. 3 is nothing but like this. 4 is nothing but like this. 5 is nothing but like this. 6 is nothing but like this. And here you can see probability of getting this for all the number is nothing but 1 by 6. Right? This is a basic example. And I will talk about what kind of distribution this is. Okay. We will discuss in depth about distribution as we go ahead. Okay. Now this is the basic way of creating a probability mass function for a discrete random variable. Now let's talk about one more very important thing, which is called as cumulative density function. Cumulative density function, which is also called as CDF. The reason why I'm telling you about CDF, because through this we will be able to probably assume many things. Okay. We'll be able to do much more calculation. We'll be able to get more information. So what exactly is cumulative density function? So let's talk about it. So here I will just go ahead and write, this is my 1, 2, 3, 4, 5, 6. So these are all my outcomes of my random variable. On the y-axis, you will be having, in the case of probability density function, is nothing but cumulative probability. Okay. And here you specifically have, let's say, I will also go ahead and write 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, and this is 1. Okay. Now, let's understand what exactly CDF is, or cumulative density function is. Cumulative density function basically means we need to combine all the probabilities as we go from 1 to 6. Okay. So what is the probability of getting 1 in this case? It is nothing but 1 by 6. So I will go and draw this particular building. Then what is the probability of getting 1 and 2? 1 and 2, right? So if I am trying to calculate the probability of 1 and 2, it is basically nothing but I'll add up 1 by 6. Then for probability of 2 also I'm getting 1 by 6. So this 2 will get added and I'll be getting 2 by 6. So this basically shows the cumulative probability of 1 and 2, right? Similarly, what is the probability of 1, 2 and 3? So it is nothing but we'll go ahead and add up this 3 probabilities, 1 by 6, 1 by 6, 1 by 6. So it is nothing but 3 by 6. Similarly for 4, it will become 4 by 6. Similarly for 5, it will become 5 by 6. And finally, this value will be 6 by 6. So overall, if I probably consider this cumulative density function, the value will be between 0 to 1, right? It cannot go above than 1, right? And this is what is the differences between the PMF, and similarly I have constructed the cumulative density function of this particular experiment of rolling a dice. Okay. Now the question rises, Krish, what kind of problem statement will be able to solve over here? Let's say that I'll go ahead and ask one question. What is the probability of this random variable to get less than or equal to 2? If I'm rolling a dice, what is the probability of this experiment to come with the value less than or equal to 2? It is very much simple to calculate it. What we'll do? We will just go ahead and write probability of x is equal to 1 plus probability of x is equal to 2. X is equal to 1 and x is equal to 2 basically means rolling a dice with 1, rolling a dice with 2. What is the probability? So once I do this, I will just get 1 by 6 plus 1 by 6, which is nothing but 2 by 6, which is nothing but 1 by 3. So this is how I'm able to get the answer. And what does this basically indicate? This indicates that the probability of getting 1 and 2 is nothing but 2 by 6, which is nothing but 1 by 3. Right? Similarly, I can go ahead and ask, what is the probability of rolling a dice and probably I get the value less than or equal to 6? Okay. So all the possible ways. So here what I will do, I will write probability of x is equal to 1 plus probability of x is equal to 2, like this, up to probability of x is equal to 3, x is equal to 6. Once I do this, I'll be able to do the calculation. At the end of the day, the overall sum over here, when I'm doing, it will be 1, right? This is the probability. So I hope you are able to understand whenever we have a discrete random variable, we can use probability mass function to showcase this entire distribution, right? And as said, what exactly is probability distribution function? It describes how the probability are distributed over a random variable. And in this case, my random variable is nothing but discrete random variable. And since we are talking in terms of probability, the value, maximum value will be 1 if I cumulatively add it up, right? Now let's talk about the next type, and very important type, because this specifically applies to a continuous random variable. It is nothing but something called as probability density function, which is nothing but PDF. Okay. PDF. Okay. Now first thing first, this is basically used for the distribution, to showcase the distribution of a continuous random variable. Continuous random variable. Let's say I have x, this is my random variable of ages. Okay, it has some values over here. Okay, now let's usually draw this distribution. And now this is really important because I'll make you understand. On the x-axis, you basically have your x, that is random variable. Let's say this is your mean 165. Okay, 165. Sorry, this is ages, right? So let's let's make it to somewhere around 40. 40 is my mean, let's consider. Okay. Now what I'll do based on this particular mean, I will just draw this probability distribution. Okay. Let's talk about this. How do we draw this? It is very simple. We first of all create a histogram, then we smoothen it, right? We smoothen this diagram. Okay. Let's draw it properly. Yeah, perfect. Okay. Now this is my mean. Okay. Now on the y-axis, usually we have something called as probability density. Now we'll understand what exactly this probability density mean. Let's say this is my age 45. If I go one standard deviation to the left, let's say it is 35, then you have 30. Similarly, you have 45, you have 50. Okay. This is how my distribution is. And let's consider this is a symmetrical distribution. That basically means 50% of the distribution of this random variable are present over here, and 50% of the distribution of the random variable are present over here, right? Now, on the probability density side, on this y-axis, you will be having some values. Let's say that you have some values like 0.01, you have some values like 0.02, then you have 0.03, then you have 0.04, and let's consider you have 0.05. Okay. Now, when I say a probability of random variable of x is equal to 40, here just by constructing this, if I just go ahead and populate this, I'm actually getting a value 0.05. Now, what does this basically mean? Does this mean that the probability of a random variable equal to 40 is nothing but 5% probability? No, right? This does not mean that, okay? And this is where you really need to understand how this probability density is basically derived, okay? Here, with respect to this PDF, I will also talk about one very important concept, which is called as area under the curve. So one, I will be talking about area under the curve. And the second thing that I will discuss about over here is that I will discuss about a very important topic with respect to this, like what exactly is this probability density and how this value is basically calculated. Okay, so these two things we will discuss now. Okay, so these two topics. Now, in order to discuss this, right now we know this is my probability density function of a continuous random variable. We will try to convert this into cumulative density function. Now, let's first of all convert this into cumulative density function. Okay. So on the x-axis, you basically have a random variable x. On the y-axis, you specifically have a cumulative probability. Now, as the term says, cumulative, okay? Cumulative, that basically means you need to combine. Again, this cumulative probability, remember, this ranges between 0 to 1, okay? Because it cannot be more than 1. Whenever we talk about probability, it is 0 to 1. And this cumulative probability usually takes a S shape. Okay, what it does, it basically takes a S shape. It takes a S shape. Now, what does this basically mean? Okay, see guys, if I probably consider what is the probability of x is less than or equal to 40. Okay, let's consider this. I'm just asking a question by seeing this graph. What is the probability of the ages to be less than or equal to 40? Okay. And here you know that less than or equal to 40 basically means this region. I'm talking about this particular region, right? And we really need to find out the probability, right? What is the probability of this random variable to be in this particular region? How do we specifically calculate it? Now see, over here, you know that your mean is nothing but it is 40, right? Now, if I go ahead and construct with this respect to 40 in this particular cumulative probability, let's say this is my 0.5. Why 0.5? Right? Because this is my median. You know that 50% of the distribution is present over here, 50% of the distribution is present over here. So if I go ahead and ask what is the probability of a random variable to be less than or equal to 40, specifically we are saying that whether this x will be available in this specific region. So we are just talking about this region, right? So if we just go ahead and calculate it, what is the probability of x to be less than or equal to 50, just by seeing this cumulative probability, I can just say that, hey, it is 50%. 0.5, which is nothing but 50%, right? Because we are talking about this specific region, right? And 40 is basically, when you plot it, you will be able to see it is coming over here, right? Now, this is very much simple, right? Similarly, if I go ahead and say, hey, what is the probability of 35 of x to be less than or equal to 35? If I say x less than or equal to 35, I'm basically going to consider area under this curve, right? This particular part. So this area under the curve. And if I probably see 35 over here, if I plot it, so what is 35? It is nothing but it's coming over here. So I'm talking about this area. When I talk about 40, I'm talking about this area. So this area is nothing but 50% of the distribution is present over here. Similarly, if I go ahead and say for other numbers, let's say 45. If I go and say with respect to 45, if I go ahead and plot it, so here I'm going to get some values. Let's say this particular value is nothing but 0.8, right? So I hope you are able to understand this, right? When I ask this specific question through cumulative probability, how I am able to understand where does a specific random variable fall, right? Which area under the curve we really need to focus. And this basically says, if I say, hey, what is the probability of x is less than or equal to 45? Now I have drawn this particular curve. This area under the curve is nothing but 80%. So it is 0.8, which is nothing but 80%, right? This basically says that this random variable has 80% probability to fall under this particular curve, right? So I hope you are able to understand, but still there rises one specific question, okay? How did we get this probability density? Let's consider for 40, how did we get this 0.05? Now for 40, what is the point? We are specifically considering this point. Let's consider this point, okay? Let's consider this particular point. In order to calculate the probability density, we need to find out the gradient, right? Gradient or slope of this point. Slope of this point. So the slope of this point in this particular scenario is highest, right? When I say slope, this line you can see it is very steep, right? This line is really, really steep, right? So if I probably go ahead and calculate the slope of this, it should be maximum. So that is the reason in the middle one that you see, like 40 number, which is my mean or median. If I try to go ahead and calculate the slope of this particular point, I should be getting the highest value since the steepness is very high. Let's say if I go ahead and calculate the slope for 50 points. So 50 point is somewhere over here, right? Here the steepness is very less, right? So obviously the slope will be less. So if you probably go ahead and see with respect to 50, I'm getting the slope somewhere over here, which is a small number. Let's say this is nothing but 0.15, okay? So wherever the steepness will be high, that slope will be highest, and that is the reason the middle number is basically having the highest probability density, and this is how the probability density is basically captured, okay? Now in order to show you how this slope may get created, okay, let's consider over here. Let's say I want to go ahead and calculate the probability density for 40. So this point we are just going to calculate the slope. In order to calculate, we'll take the previous point. Let's say this is my previous point, okay? This is my previous point and this is the above point near 40. We'll take the nearest point out of it. Okay. Let's say this value is 166. Oh, sorry. This value is 44. This value may be 38. Okay. So how do we specifically calculate this? Okay. And with respect to this particular point, we also go ahead and calculate the slope. Now, in order to calculate the slope, it is very simple. Okay. We take the nearest point, that is nothing but 44 minus 44, sorry. Okay. So let's see this. Okay. So first of all, what we'll do, we'll first of all go ahead and calculate what is the probability for this. What is the probability for this? Okay. For this 38 and 44. For 38, let's say I'm getting a probability of 0.45. Here I'm getting a probability of 0.65. Okay. So the slope will basically be calculated by 0.65 minus 0.45 divided by whatever numbers that I have over here, 44 minus 38, right? This is the slope formula. Okay. So let's say that I got some number, whatever number that I'm able to derive it from here, I'll go ahead and write it over here. Or whatever calculation, I've just put some random values over here. But if I put the original value based on this particular diagram, here you'll be able to see that I'm getting 0.05. Okay. So whatever calculation you do, just do this particular division and you should be able to get your probability density. Or I'll just not write 0.05 over here. I know the calculation is not 0.05. So by this, you will be able to get your probability density. Now you may be thinking, Krish, what did I do over here? Simply I calculated slope. Let's say if I have 2 points like this, in order to calculate the slope, this is mentioned by x1, y1. Let's say this is mentioned by x2, y2. So in order to calculate the slope, the formula is very simple, right? x2 minus x1 divided by y2 minus y1. So this is the formula that we usually use to calculate a slope between 2 points. But we need to calculate the slope with respect to a single point. So we can take the 2 nearest point and we can calculate it. So this is the formula that we have specifically used to calculate the slope. We can also say this slope as gradient, okay? This as gradient. And that is how we calculate this probability density. Probability density. So if in interview they ask you, hey, what exactly is probability density? Okay, what exactly is probability density? Then here you can basically go ahead and just define. It is nothing but it is a gradient. Gradient basically means derivative. Gradient of cumulative curve or cumulative density function, right? And that is the reason this cumulative density function is really important. It is nothing but it is a gradient of cumulative density function. So I hope you are able to understand. You also understood about this 2 terms, area under the curve and how to calculate the probability density. Okay. And this is how you can probably represent any distribution with the help of probability density function. So yes, this was the video. 3 important topics we have discussed over here. I'll also go ahead and write the third topic, which is necessary to understand about probability mass and density function, which is nothing but cumulative distribution function. Okay. Cumulative basically means we're just combining. Okay. And this is nothing but this is represented by CDF. So I hope you like this particular video. This was it from my side, a very important video. Now in the next video, we are going to see the different types of distribution. Before closing up, I also want to represent some mathematical representation probability density function. Okay. So probability density function. So let's talk about some of the properties over here. Okay. Some of the properties. Okay. I'll write like this. I'll write PDF properties. PDF properties. Okay. So the first property is nothing but it is always non-negative. What is non-negative? Non-negativity. Okay. So here the function that will be used to create this entire probability density function. See, there should be one function which will take this number and should be able to create your probability density. I know this is how gradient is basically calculated and we get the probability density. But mathematically we use a specific function. So here I'm going to denote it by f of x of 0. So for all x values. Okay. Second thing, the total area under the PDF curve, I'll explain the first point in much more detail right now, is equal to 1. Okay. Now what does this basically indicate? See, this is how we basically denote it. Okay. So an integration value from infinity to minus infinity to infinity. This is the limit. Okay. We use a function f of x, d of x is equal to 1. That basically means this notation represents area under the PDF curve. This entire area under the PDF curve, this entire area. It is nothing but this area. So this distribution is basically created by this particular function f of x. Okay. This can be different things. See, I may have a distribution which may look like this. I may have a distribution which may look like this, right? I may also have a distribution which may look like this, right? So this distribution is basically created by this function f of x. And as we know, when we do this, when we use this notation from a specific limits, right? The total area is just going to be 1. The total area of this, the total area of this, the total area of this is just going to be 1. Okay. So with respect to different distribution, so here I'll go ahead and write with respect to different distribution, your f of x function will change. The f of x function is going to change. Okay. And that is what we will be discussing when we discuss about different distributions, different distribution types. There are around 8 to 10 distribution types, like normal Gaussian distribution, you have normal distribution, normal or Gaussian distribution, you have log normal distribution, you have binomial distribution, you have Bernoulli distribution. In all this kind of distribution is basically used to represent your random variable in the form of probabilities. And there, in order to calculate the probability density or probability mass function, we specifically use a function, and this function f of x will be different for different types of distribution, right? Let's say if I have this kind of distribution, right? So there will be a different f of x function which will be creating this. Based on this, I will be getting a probability density over here. If I have this kind of distribution, this is also called as a log normal distribution. Okay. In this log normal distribution, the f of x function will be different to calculate the probability density. And that is what we are going to discuss in the upcoming video. Okay. So, but remember this particular notation, f of x dx is equal to 1. Okay. Okay. So I hope you like this particular video. This was it from my side. I will see you all in the next video. We'll discuss more about the further topics.